In order to get the understanding of the mathematics, and the reason we use this idea of bells is because the mathematics to it is close enough for our measurements, maybe not completely accurate if we did the mathematics with the actual amount of AC current that's received. That mathematically would be very difficult. So the idea is that so part of the actual equation deals with logarithms. Now, I don't know if you remember about logarithms from times you were in math class, but the term log with the subscript 10 just means that we're using a base 10 system. A base 10 system means that we have those digits, right, from 0 through 9 in our numbering system. Whereas if we used a base 2, which we called binary, the only digits are 0 and 1. If we used hexadecimal, it's a base 16, so it uses from 0 through the letter F. So it's about how many digits we have, and base 10 is what we're used to in our most of our numbering systems. And because we're doing a ratio of 10 to 1, then we're going to be using base 10 for the logarithms. Now the idea then is that if we were to look at a number like 10 to the first power, well, we know that 10 to the first power is 10. At least I hope we know that. And so the logarithm that we would use to figure out what the exponent was of this setup would be 10, the number that we had, times the log of 10 to the base 10 of 10. So the log in base 10 of 10 is basically asking us what that number was, that exponent. And so the same thing we would have if we add 10 to the 2, that's 100. And by the way, it's not 10 times the log. I'm sorry about that. That's just the number 10. Converting what, in this case, 10 to the second power is 100, 10 squared. So then if we said, what is in base 10 the logarithm of the number 100, then we would get the exponent. And it continues to go that way, right? If it was 10 to the third, that actually starts off as 1,000. And so, we keep going through that. Now, that's a bell. That's how we're doing this comparison for the number of bells. A dB, or decibel, is 1/100th of a bell. And the way in which we calculate those is we actually use the number 10 multiplied by the log of base 10 of the initial power versus the received power. So if you think about it this way, in that last comparison, we're talking about the initial power, which was 100, and when it was received at 10 milliwatts, so these are milliwatts, and when we do that division, 100 divided by 10, then we come up with the answer 10. And we know that the log of 10, right, to the of the number 10 is going to be equal to 1. And so that's going to be, and again, now you might say, well, wait a second, you said that the 10 to 1 was 1 bell. Yes, I said it was 1 bell, but we are talking about decibels. So that, again, 1/100th of it. So that's where we would say, okay, the log in this case would come out as 10, and that would be 10 decibels as opposed to how many bells it would be.